In this video, we're going to talk about solving some trigonometric equations, and what I'm going to do is, instead of finding all solutions, I'm just going to find solutions to these equations that fall in the interval 0 to 360 degrees. And also, just for my own sake, I have put part of the unit circle over here. So just as a refresher, really for myself more than anything. So let's solve a couple of these. So, as our first example, let's solve, say, 2 cosine of x minus 1 is equal to 0. To solve 2 cosine x minus 1, the way I think about it, if I see basically a cosine to the first power, the same way that you would solve if it just said 2x minus 1 is equal to 0. The same way that you would solve that problem is the same way that you'll solve 2 cosine x minus 1. And in this problem, you would simply add 1 to both sides and divide by 2. That's the same thing we're going to do on this problem. We're going to add 1 to both sides and get 2 cosine of x equals 1. And then we'll simply divide both sides by 2 to get cosine of x equals 1/2. So now I have to think about angles on the unit circle. And remember, cosine represents the x-coordinate, so I find the first place where my x-coordinate is 1/2. And one place where cosine of x equals 1/2 is at the angle 60 degrees. So that means x equals 60 degrees is going to be a solution. And on the left side of the unit circle, all the x-coordinates are negative, so that won't be a solution. But if you reflect that angle down, that will be another solution, and that's going to give you the angle 300 degrees. Because again, the whole distance around being 360 degrees. If you go 60 degrees less, you're at the angle 60 degrees. So, those would be our solutions for this equation in this example. So let's do a couple more of these, some that are maybe a little more difficult. So, suppose we have sine of 2x equals cosine of x. One trick to solving these problems is going to be to simply use trig identities. And there's a trig identity for sine of 2x that says that's equivalent to 2 sine of x by cosine of x. And on the right side, we still have our cosine of x hanging out. And on this stuff, you have to be careful. A lot of people will have a tendency to simply divide both sides by x, which is not correct. You end up losing solutions that way. It's kind of equivalent if you were solving the equation x squared equals x. If you were to divide both sides by x, you would get simply that x equals 1, which definitely is a solution to the equation x squared equals x. But the problem is, 0 is also a solution. And you get 0 as a solution by subtracting x from both sides, factoring, and then setting each piece to 0. You'll get your 0 solution, and you'll get your other solution of 1 as well. So in general, what you need to do is to set equations equal to 0 and to factor them. So that's what we're going to do on this one. If you divided by cosine of x, it would be equivalent to dividing by x, and you would end up losing solutions. So we'll have 2 sine of x by cosine of x, minus cosine of x, equals 0. Well, now I can factor my cosine of x out of both factors, and I'll be left with 2 sine of x, minus 1, equals 0. And now I set each piece equal to 0. So I'll have that cosine of x has to equal 0. Or I'll have 2 sine of x minus 1 has to equal 0, and adding 1 and dividing by 2 will get sine of x equals 1/2. So let's think about places where cosine equals 0. Again, going back to our unit circle, cosine is the x-coordinate. Well, the first place where the x-coordinate is 0 is at 90 degrees. It's also going to be 0 at the bottom of the circle, which is 270 degrees. So we'll have 90 degrees and 270 degrees being our solutions for the first part. And then to figure out where sine of x is 1/2, again, I have to think about angles. And the y-coordinate is represented by sine. So the first place that sine is 1/2 is going to be at 30 degrees. Likewise on the other side it's going to be 1/2, which is going to be the angle 150 degrees. So we'll get x equals 30 degrees and 150 degrees as our solutions to this problem.